All right, this mini lecture is going to look at two different things. The first is how we define objects according to their electrical properties. And the second is how do we actually even get charged particles? What do we need to do to get a charged object or to charge an object? So, how do we define objects in terms of their electrical properties? We move them into two categories. The first category is called an insulator. The second is a conductor. So what is the difference between insulators and conductors? In an insulator, charges do not move throughout them. So electrons do not move through an insulator. In a conductor, electrons move freely throughout a conductor. So what does that look like? And one common misconception that we'll figure out when we talk about what it looks like is that insulators can't be charged. They can. Both insulators and conductors can be charged. They can become charged objects. Just what they do with that charge is a little bit different. So let's start with the insulators. Now, insulators tend to be things like plastic, rubber, that sort of material. Well, remember that balloon example that we used in our first video on static electricity? If you haven't seen that, go back and check out that video on static electricity and introducing charges. Well, we took that balloon and we rubbed it against our head. Well, an imaginary balloon. Well, a balloon is rubbery. And we stuck it to the wall. And we talked about polarization and the interaction of charged particles, the balloon, and neutral objects, the wall. Well, the balloon was charged. So I can charge an insulator. But if we zoom in and look at what happened to that balloon. Well, if I have that balloon and I put a whole bunch of negative charges on this one side of the balloon, I'm rubbing one side of the balloon, I put all those negative charges on that side of the balloon. And that's where they stay. They stay put. They don't move throughout the balloon. They just kind of collect right there where I rubbed it against my head. You can test this because if you rub it against your head and stick the part you rubbed against your head on the wall, it'll stick. But if you turn it around and stick the part that you were holding against the wall, it doesn't stick. It starts to fall, it starts to twist, and eventually it sticks because this part touches the wall. But no electrons have moved through the balloon to this side. All right, well, it's different than a conductor. If I have a spherical conductor, or any shape, but we'll use a sphere, and I put a whole bunch of electrons on this side of the conductor by adding electrons there, instantly, those electrons will spread out throughout the conductor. Right away, they'll hit that surface and they'll spread out. Why do they spread out? Well, they're negative charges, and there's a whole bunch of them all together. And negative charges don't like other negative charges, right? They want to spread out. So they do, and they do it immediately. So a conductor can allow those charges to spread out. All right, well, insulators and conductors are going to be important in our discussion of ways we get charged particles. So that's where we're going to move to next. We were able to get an object to be charged through rubbing it viciously across my head. And that's going to be our first way we discuss the way we can get charged particles. Let's get a little loud. So imagine we rub that balloon against the head, or you may have had the experience where you're walking along your carpet, especially if you have like 70s shade carpet, and you're walking along that carpet and you touch a door handle and you get a shock. You might have had that experience before. Well, that's one of the ways we get charged particles. That physical ripping of electrons off of one surface onto another is our first one we're going to talk about. Charged particles or charged objects. We call that physical manipulation. We're literally ripping electrons from one surface and plopping them on another surface. Violently. Stuffing our carpet, rubbing it against our head. But how do we know which ones the electrons come off of and which ones the electrons go into. If I rub the balloon along my head, does my hair become negatively charged and the balloon become positively charged, so the electrons went to my hair? Or is it the other way around, where the balloon becomes negatively charged and the hair becomes positively charged because the electrons went to the balloon? How do we know? Well, this is something we can look up. When two objects interact and physical manipulation is happening, one of them more easily accepts the electrons, becoming more negative, and one of them more easily gives the electrons, becoming more positive. And we can know that by looking at what's known as the triboelectric series. This is a series of elements, of items, of objects, from top to bottom, if we look at it in a linear list. And at the top of that list, those objects are more likely to lose electrons. They're more likely to become more positive. And at the bottom of that list, those are objects that are more likely to gain electrons. So they're the ones that are more likely to become negative. So when you have two objects that you're manipulating between another, you look at their relative positions on the list. If they're higher on the list, they're more likely to become positive. They're more likely to the ones lose the electrons. Similarly, lower on the list. So that's physical manipulation. Now let's go back to that example where we're scuffing our feet against the floor and I go touch a doorknob. What happens? Oh, I get a shock. Why did I suddenly get a shock? Well, that shock is the transfer of electrons. Well, how did that happen? I just touched the doorknob. And that's the second way. And that is just physical contact. No rubbing, no manipulation, just touching, just contact. There's something special about this way, though. We have to have a conductor. So you cannot charge an object by physical contact. That's an insulator. It has to be a conductor. And why might that be? Well, if I bring a charged rod, let's say it's full of negative charge and they're all over this rod, and I bring that to a conductive surface. So here's my conductor. Those negative charges now have an ability to spread out because they can move through that conductor. So they're going to go and they're going to spread out through that conductor. And when I remove that rod, those negative charges are now on that conductor. Just by touching the conductor, we get a charged object. So physical contact, just touching, can work. But it only works if we're dealing with conductors. All right. The third way we can get a charged object is through a process called induction. No contact necessary. So let's imagine that we have a rod that is full of negative charges. And I bring that rod close to I don't touch it, but I bring it close to a conductive sphere that's connected to the ground. The ground, the physical ground, allows electrons to flow up or out. Okay, either way, lots of repository for electrons, lots of space to move out. So as I bring this negative charge towards this sphere, the electrons in this area are like, whoa, negative charge is coming, I don't want one of those. And they start to run away. They start to go out into the ground. So our negative charges move out into that ground. Now, here's an important step. Before I move the rod away, not touched it, I take this charge, this sphere that the electrons left, and if the electrons left, what's got to be left over? An excess of positives, because there's a reduction of negatives, and I remove it from the ground. Well, now electrons can't leave anymore, and there's less to leave because some of them already left, and I'm left with a positive charged sphere. And then if I remove the rod, I can leave it there, doesn't really matter. I'm left with a positive charged sphere. So I've not touched anything. I've just induced a charge. I've manipulated the charges in their motion so that I can get a charged object. Now, order was very important. Had I left that sphere there and my ground was there, had I removed the sphere first, the rod first, before the ground was removed, those electrons would have flown right back into that sphere, just like that, and I wouldn't have had a charged sphere. So we have to remove the ability for those electrons to move anymore, and then remove the inducer itself. All right, so insulators and conductors are important physical electrical properties of objects that actually make a difference when we're thinking about charging objects. And these are the 3 ways that we can get charged objects. All right, good job.